Mountains tend to be narrower at the top than they are at the bottom, otherwise they'd eventually fall down. But that doesn't mean that mountains are always smaller at the top, because what matters to most land creatures is the amount of land. That is, the surface area, not the volume. Unless you're a mining company that plans to pulverize the entire mountain into smithereens, then volume matters. But to the rest of us, we care about surface area. And surprisingly, the area of land on a mountain doesn't necessarily get smaller as you go higher up the mountain, especially when that mountain is part of a mountain range, as mountains tend to be. Simple, lone mountains with shapes like cones or inverted parabolas do indeed have less surface area the higher up you go, though a parabolic mountain has a lot more area high up than a spiky mountain. Broader, flatter mountains can actually have more area the higher you go up, at least until you get to the very top. These mountains do get skinnier as they go up, but they get flatter so much faster than they get skinnier that from the perspective of available surface area, they're bigger on top than at the bottom. And when you put mountains together into ranges, it's even more complicated. Some ranges have less land area the higher you go up, some have more area, some have more, then less, and some actually have more area at both the bottom and top, and less area in the middle. In fact, if you do a survey of mountain ranges the world over, you'll find that only around a third of them have a constantly decreasing amount of land the higher you go, and the rest exhibit one of the other weird top-heavy options. In other words, despite appearances and as odd as it sounds, most mountain ranges are bigger near their tops, which has interesting implications for any land-dwelling creatures that might want to move their homes and businesses up or down mountains, if, I don't know, the climate changes or something. And one more weird fact, a perfectly hemispherical mountain, which is probably impossible in reality, has just the right shape to get skinnier at the same rate that it gets flatter, so it has amazingly the exact same amount of area at every elevation. The same math also means that if you evenly slice an orange, each piece will have roughly the same amount of skin, but different amounts of fruit.